Okay guys, Craig here. I just thought I'd run over my CNC mill for you guys just to show you what it's made of and how it works. So I wanted to design one, and by dumb luck I happened to head down to our local metal scrap dealer, and they had some of this hidden way around the back. So this is 40 by 80 extruded aluminium T-track channel. So luckily enough, they didn't know what this was worth. So I managed to get I think it was 3 4-meter sticks, and they only charged me weight value. So might have been $45 for the whole lot. As you can see, that was enough to build this whole frame of the CNC. So it's about 1,500 long by about 1 meter wide. And obviously on the Y-axis here, we're doubled up. So the idea of this profile is that you can run tapered V bearings in the channel like this. This is very dimensionally accurate. You can see the backlash is very minimal. Everything's really solid and rigid. I mean, you can't even hear any movement in that at all. I've been running this machine now for a couple of years, and it's just starting to make an impression in the aluminium. If I do start to get a wee bit of backlash or tolerance in these here, I think I'll just end up putting another bolt through here, slotting this out a wee bit so I can put an adjustment nut on it and just tighten it down so it's nice and snug again. But at the moment, it's running very well. So yeah, on this, I'm running lead screws for my drivers. That's what's limited me to the size of this bed. As I say, I had 1,500 chassis. I'm running linear bearings. So I've got 2 on each foot on the x-axis. And I would have liked to have run this right out to the full length of these. So these actually run all the way under here at 1,500 long. But for me here, the limiting factor is these lead screws. The cost of these, when they go up to the next length, isn't too bad for the part itself, but the shipping, for me to get that to New Zealand from China or America, is in excess of 3 times the part value. So I was looking at $200 alone just for shipping. And at this stage, I haven't needed to invest in it. But these lead screws have run really well. So I run them one over here, one here, and one on my Y-axis as well. And I've got one tucked in there on my Z-axis as well. I think they're T2, 8mm or something like that. Run really well. So I'm running that with NEMA 23s. So I've got one on top of my Z, I've got one on my Y there, and I've got 2 on my X, so one here and one over there. And they run in parallel to each other. I actually run them off the one driver here, which is wasn't sure how it would go, but it seems to be perfectly fine. Like if I tried to hold that machine back, it would actually pull me off my feet with plenty of torque and plenty of power. So here we've got our 3 stepper drivers, X, Y, Z, and they're just your sort of run-of-the-mill. I'm sure everybody's seen them before. Running a pretty simple Arduino Uno with GRBL on it, and then I've just got my power supply running at 40 volts. As I say, I'm pretty happy with the way it's running, but if I did need a bit more power or speed, I could actually run another power supply for each driver to get a bit more speed. But as it is, I'm pretty happy. So the spindle's just, again, it's from a Chinese spindle, 500 watts. I think it's ER20 collets in there. I used to run a router system, but just extremely noisy, and there's no variable speed on it. Whereas this wee baby here, it's only brushless, but I can adjust the speed. So you can actually do that through the software, but I tend to just do it by hand. That noise you heard is just the cooling fan on the top's actually just loose on the shaft. So when I spin the motor up, it takes a second to spin up. Probably should fix it. Yeah, so for most of my parts, I use, if I'm doing decorative parts like a lot of these are, I use Easel. It's quite a good software. I can import SVGs or pictures and convert them into what I want. So I just then design the depth of cut, what I'm cutting it with, and the speed and feed. So you can alter all of that. I can import whatever end mills or bits I want. So a lot of these will be done with, so these are all done with a V-bit, and then they're resin inlaid, and then I mill the top off just to make it all nice and smooth. These ones here, most of these wooden ones that I do with just a 2-blade tungsten router bit. So basically just, basically these hog out material really quick, really cheap. And then I'll do my finer stuff. I'll get smaller and smaller. So I'll normally do a detailed and a rough, depending on how small. These are my V bits. I go down pretty small with them. They get pretty accurate cuts. Yeah, so there's my collar. There's a single flute, 3mm for cutting aluminium. I use that quite often. Use a couple of bull noses and a couple of hardened tool steel end mills, just depending on what I'm doing. Yeah, so the more 3D designs, I use Fusion 360 for these. It's quite good for that because I can set different parameters, different ways I want it to cut, you know. It's really good. So I've done a couple of these. Did this one out of alloy just to play with some settings. Come out pretty good, really. I just ran a wire brush over that to get some surface finish because it was a wee bit rough. Time was actually reasonably fast on that. I thought it might be a bit longer. This is just my sample stuff that I've used playing with my speeds and feeds. A lot of the other parts I've made are actually out of the shop on parts and bikes and stuff like that. There's a wee bit of perspex I did with just a wee 2-blade end mill, basically a router bit. Pretty cool. You can do some cool stuff with that, but I haven't really been into it too much. Stainless steel, managed to do a pretty cool sign. I did a timber inlay with stainless steel letters inlaid into it. I might put a photo of that up. Had quite a lot of trouble, as you can imagine, sorting the feeds and speeds out with this. Ended up using a full tungsten router bit and snapping countless times because, of course, with stainless, the tool hardening. So if I didn't get the feed exactly right, slightly too fast, it would heat up and break the end mill. So well worth it, but a lot of time spent in it. Yeah, so run you now through, just run it up and let you have a look. So I've designed a wee thing in easel, put it into the UGS, which is just your platform to convert the G code into, so your Arduino can read it. So what am I going to run? I'm just going to run this here. I've already started running it on the first one, but I'll run it again. So return to 0, make sure we're where we need to be, and then we'll just go send. Yeah, so I won't bore you too much, but there we go. If you want me to see me cutting something at some stage, just post it up and I'll get something running for you guys. All right, thanks a lot.